For problem 3, we're being asked to find out which one of these numbers, and only one of them, is a perfect square, meaning that it's the square of a whole number, not any decimals or fractions. So when we're thinking about this, and my hint says don't reach for a calculator, think about the properties of numbers. So you notice here on my board that I don't write down all those numbers, 1, 2, 3, 4, 5 numbers that we have to consider. I don't write them down. What I wrote down were the 10 digits that we have in our number system. And the reason I wrote this is that whatever numbers are there, we have the 5 numbers that are in the problem. If one of them's a perfect square, then the number that was squared to get to it has to be, the very last digit in the ones place has to be one of those digits. So if we square each one of these digits, then we will see what the last digit is of any number that contains one of these as the last digit and then squared. Does that make sense? So let's look at this way. What if my number is 164? Well, if I square 164, it doesn't matter what all the other digits are. The fact is the very last digit on the right is going to be the product of the ones place digit by itself, like 4 times 4 is 16. And all the other numbers in this perfect square are going to be to the left of that. So all we really have to do is think about what are the possible rightmost digits in the 5 numbers that we were given and see if any of them match up to a perfect square. So I wrote down all 10 of them, 0 through 9, and if I square them, then I get 0, 1, 4, 9, 16, 25, 36, 49, 64, 81. And I see that the digits, the rightmost digit are 0, 1, 4, 9, 6, 5, 6, 9, 4, 1. Isn't this interesting? And if we thought about 10, then this would be a 0 there. So look, we have 0, 1, 4, 9, 6, 5. And mathematicians love these sorts of patterns. We love seeing what those patterns are. But the fact is any number that's a perfect square can only end with 0, 1, 4, 9, 6, and 5. 0, 1, 4, 9, 6, or 5. There's no way to square a number and get 3 or 2 or 7 or 8. So when we look at the list of numbers that we were given in the problem, we see that the first one, 3, 2, 9, 4, 7, 6, ends in a 6, which is something that you can get in a perfect square. The others end in 2, 8, 7, and 3, which there's no way you can get them. So without reaching for a calculator and trying to take the square root of each one of these numbers, we just think about the properties of numbers. And we say, if it's a perfect square, it can only end in 0, 1, 4, 9, 6, or 5. One of them ends in 6, so we know that that is the only one that could be a perfect square.